So here in this problem, we have two trigonometric functions, sine of A, which is half, and cosine of B, that's 12 over 13. Using this information, we need to find out the value of tangent of A minus B. Fine, so let us begin. So let's first define tangent of A minus B. Now tangent of A minus B, when we expand it, this is going to have the form tangent of A minus tangent of B divided by 1 plus tangent of A multiplied to tangent of B. Right. So this is what we need to find. We need to find out the value of tangent of A and tangent of B. That is going to help us find out tangent of A minus B. So let's label this as equation number 1. Now, we have been provided with sine A and cosine B. So using sine A, we have to find out tangent of A, and using cosine B, you can find out tangent of B. Right. We can use trigonometric identities to find out tangent of A, but what we are going to do here is find out the value of tangent of A using a trick. The trick being, so we have here sine of angle A, so that's equals to 1/2. Let us consider a triangle. We have the triangle A, B, and C. It's right angled at C. Now, if we define for sine of angle A, we know that sine of angle A, that's defined as the ratio of the perpendicular, which is BC, to that of the hypotenuse, so that's AB. So since this is a ratio equals to 1/2, so we can consider BC to be equivalent to 1 unit and AB, the hypotenuse, to be equivalent to 2 units. Now, ABC being a right angle triangle, we can use the Pythagoras theorem to find out the value of our third side, which is AC, and the third side is simply going to be equals to square root of 3. Now that we have the value of the third side AC, we can use this information to find out the value of tangent of angle A. Now tangent of this particular angle A, that's the ratio of the perpendicular BC to that of the base AC. So BC value, that's 1, and the AC value, that's going to be square root of 3. So we have tangent of A, that's 1 over square root of 3. But we'll have to be careful about the sign. Here it's given here that angle A, that lies between pi over 2 and pi radian. In which quadrant does it lie? This implies that A lies on the second quadrant. This is the second quadrant, and in the second quadrant, tangent function is negative in nature, because only the sine function and its reciprocal, the cosecant function, is positive in the second quadrant. Everything else is negative. Since tangent is negative, so our final value must be a negative value. So this must be equals to negative 1 over square root of 3. We have now the value of tangent of A. So next we'll try to find out the value of tangent of B. So here we're also given the value of cosine of angle B. So cosine of angle B, so that's given as 12 over 13. Now we're going to construct a new right angle triangle. So we're going to consider the new right angle triangle ABC, right angled at angle C. Now here it's given, if we take cosine of angle B, then according to this new triangle ABC, then in terms of its ratio of the sides, that will be the base BC over the hypotenuse AB. It's given here that BC over AB, this ratio is 12 over 13. So we can say that BC has a measure of 12 units and AB has a measure of 13 units. And it's ABC being a right angle triangle, we can immediately find out AC, and also 5, 12, 13 forms a Pythagorean triplet. So AC measure is 5 units. Now that we have the measure of AC, we can use this to find out the value of tangent of angle B. So tangent of angle B, that will be the ratio AC over BC, which is equals to 5 over 12. We'll have to find out the sine as well. So it's given here that angle B lies between 3 pi over 2 and 2 pi. This means that our angle B lies on which quadrant? It lies on the fourth quadrant. Now in the fourth quadrant, only the cosine function is positive, so everything else being negative. So we have tangent of B giving us a negative value. So this gives us a negative value. So our result will be negative 5 over 12. Now we have the value of tangent A as well as tangent of B. So we can use equation number 1. So let's do it here. So equation number 1 gives us the value of tangent of A minus B. So this will be equals to tangent of A. So that's negative 1 over square root of 3. Minus, we have tangent of B, which is negative 5 over 12. So we'll get positive 5 over 12. Whole divided by 1 over square root of 3 multiply to tangent of b, which is negative 5 over 12. Fine. So let's solve this. We have a common denominator, which is 12 times square root of 3. So we are going to multiply both numerator and the denominator with 12 times square root of 3. So we're going to get the result 5 square root of 3 minus 12 divided by, we're going to have 5 plus 12 times square root of 3. So this is going to be the result of tangent of a minus b.